Hi, I'm Sanjay Nagchaudhary, Development Lead for the IBM App Connect Enterprise product. In this video, I will describe changes that we've made in ESQL so that you can reference a specific location in the context tree using the contextreference function. I'll also demonstrate how to use the contextinvocationnode function to access the input message. In the previous video, I introduced the context tree and gave an example of how to access the payload data from earlier nodes in the message flow. The context tree is a new tree in the message assembly, which is not captured by default. It is only made available in the message assembly when it is referenced. In the ESQL example on the chart, I used context, which is a read-only correlation name that can access the current context tree. There are also two ESQL functions which can be used, which are contextreference and contextinvocationnode. So the contextreference function can return a named node section from anywhere in the call path. When it is used, context trees are enabled for the message flow that is using the function. It can either take one or two parameters. The first parameter is the node label. The optional second parameter can be used if there is a clash in node names in the message flow. This may occur if a subflow was invoked by several subflow nodes in the message flow. So the function is particularly useful when it is used in a compute node in a subflow. The contextreference function also supports parameter keywords, which has a similar format as other ESQL functions. The contextreference function was first made available in 13.0.4.0 and was extended in 13.0.5.0. The parameter keywords that are supported are node name, level name, payload, payload details, headers, and metadata. Note that only one of payload or payload details, headers, and metadata can be used at a time. Some examples are shown on this slide. The contextinvocationnode function can be used to access the input message. In fact, the most common use case for a message flow is to access the original input message. And before context trees were added in 13.0.4, the only way to save the input message would be to use the environment tree, or perhaps to use a shared row variable in ESQL, or possibly using a global cache. The contextinvocationnode function has been added in ESQL to save the flow developer from having to know the name of the input node in the message flow. The message flow shown on this chart shows there are two HTTP input nodes. When the flow developer is using the contextinvocationnode, they do not need to use the node label. So the contextinvocationnode function is very similar to the contextreference function, except it does not take a node name or level name as a parameter keyword. When the contextinvocationnode is used, the context trees are enabled for the message flow, and the contextinvocationnode function can also use payload, payload details, or headers or metadata, but only one of these can be used at a time. So this is the flow that I demonstrated in my previous video. I have a HTTP input node which receives an input message. I have two REST request nodes, each calling a different backend REST API. The REST APIs are deployed to my integration server. Each REST API has a single operation, and it takes a query parameter and converts the input data to uppercase and returns it in the output message. The two REST APIs have been imported from a tutorial called Aggregation Nodes using REST Async Request Nodes with Backend Services. You can import that tutorial by opening the tutorials gallery, and if you search for REST, you can see the tutorial and you can then import the projects from that tutorial. The compute node in the flow takes the input message from the input node and the payload data from each REST request node and forms a response, and then the response is sent back. I'll just redeploy this flow to the integration server, and if I send a message to the flow, you can see that it has taken the input message, it has taken the output from the first REST API and output from the second REST API and formed a response message. I'm now going to change this flow to use a subflow. I will just move these nodes out of the way. I'm going to create a subflow in the application. I'll call it use context. I'll add a compute node. And I will copy the trace node. I have a subflow, and in my compute node, I will just remove these procedures which are not needed. Initially, I will just try and use this original ESQL that I used in my first video. Try and use it in the compute node in this subflow. This will not work, but I will just demo what changes need to be made. So I'm trying to form a response message from the input message and from the two REST request nodes. So let's use a subflow node to call the subflow. And let's just remove these two nodes from the flow so it's tidied up. Save that message flow. Okay, so let's redeploy the application to the integration server. And now when I send a message to the flow, I'm getting an empty response message back. So it hasn't worked. Let's see what changes need to be made in the compute node in the subflow. So in order to access the input message, I'm going to use the contextinvocationnode function. So first of all, I'm going to declare a variable which references the payload of the input message. So I can do this by using the contextinvocationnode and specifying the payload parameter keyword. Next, I'm going to declare a variable to access the payload from the first REST request node. So I'm using contextreference, and I'm specifying the get backend 1 REST request node. And now I'm going to add another declare statement, and this is for another variable, and this is referencing the second REST request node and accessing the payload information. I'm going to change these set statements, and initially let's just comment these ones out, just leaving a bit there for a moment just so that you can see the difference in what I'm going to do. So in the first one, I'm just going to access this variable here and then specify .data, then the name element in the payload. And then for the string 1 element, I'm going to access the second variable here. I'm simply going to use data.output1. So this is the output in the payload of the REST request node. And now I'm going to specify third variable, and again I'm going to use data.output2. So that is the name of the output element in the payload that comes out of a second REST request node. So you can see here I'm accessing these variables here. So let's just remove those lines, and you can see I'm using the contextinvocationnode to get to the input message, the contextreference function to get to the payload from the first REST request node, and contextreference to get access to the payload from the second REST request node. And I'll save that and save the flow. Let's deploy the application. And let's put a message through the flow. And this time you can see that it has successfully received the response. Let's just show using the flow exerciser as well. This can show the path taken and show the message assemblies. The same input message. And you can see the response is returned. And before the call to the subflow, you can see in the context tree the nodes that are used. The context trees are made available because the functions are used in the compute node, which is in the subflow. If I go into the subflow, when you're in the subflow, when you look at the message assembly, you can only see the data that comes into the messages into the subflow. So here you only see the input. So this is the input that comes into the subflow. So that's the output from the last REST request node. So this is why it is handy to have these functions to access the data in the call path. So I'm able to access it using the contextinvocationnode function and the contextreference function. And you can see that the output response is created. Let's make one more change to the flow. And what I'm going to do is to create another input node. Okay, so first input node, let's just rename it to HTTP input Sanjay. And this one, let's change it to HTTP input Ben. Let's go back to the first one and change the URL suffix to context-demo-sanjay. And on this second one, let's use /context-demo-ben and make sure input message parsing is JSON because I'm using a JSON message. So I have two input nodes here. And we'll see that the contextinvocationnode function doesn't need to know the node label it uses for call path to work out the input message and which node it came from. Okay, it's just saving the flow. I'll redeploy. Okay. So let's send a message to the flow. So this is going to use the first input node, and you can see it gets a response back. And if I click on the message assembly, we can see that it has worked out that it's come from HTTP input Sanjay. So that's where it's useful to use the contextinvocationnode. Let's just, for completeness, send a message to the other input node. So let's change it to Ben and send it to HTTP input Ben, and you can see the response has got a name Ben in the response message, and you can see in the context tree that input node Ben has been found with the payload. So in this video I've demonstrated how to use two new ESQL functions, context reference and context invocation node. This allows you to access the context tree.